Let's take a look at some more examples involving I. Here we have rad 3 times rad negative 27. Let's take a look. We want to find a perfect square as a factor of 27. So let's do a factor tree here. I'm thinking 9 times 3 will do the trick because there's our perfect square. 9 is indeed 3 times 3. Okay, so let's factor that out. So we have our rad 3 still hanging around in the front. I'm just going to, you know what, this negative inside, that just comes out as an I. Right, so an I comes out, and we're left with 27, which is rad 9 times rad 3. Okay, well, let's rearrange things a little bit here. Rad 9 is 3, and then we have our I, and then here we have rad 3 times rad 3, which again, those combine to 9, rad 9, which is 3 again. So this is times 3, and let's simplify that down to 9I. There we go. Okay, let's take a look at B. Now B is an interesting case, perhaps far more interesting than it looks, because there's almost a little paradox tucked in here if you're not careful. First off, right, so negative 11, negative rad 11, we can think of that as rad negative 1 times rad 11, which is I rad 11. Okay, so let's do that for both of these. So this becomes I rad 11 times I rad 3. Well, rearranging gives I squared rad 33 because we can combine inside a single radical here. But remember, I squared equals negative 1. That's one of the definitions of what I is. It's the number that when you square it, it gives you negative 1. Fact. So this becomes negative rad 33. That's the correct answer. But let's look at a wrong answer for this. Okay, so now I'm going to combine these under a single radical. So this is rad negative 11 times negative 3. Well, negative 11 times negative 3 is positive 33, rad 33. Do you see the problem here? Here's what's going on. The rule for combining radicals, rad A times rad B equals radical AB. We kind of take this for granted, but there's more to it. If you carefully look at this rule, it continues. It says if rad A and rad B are real numbers. Okay, so you can only combine them like this if rad A and rad B are real numbers. In this case, they are not real numbers. So we can't combine them under a single radical. So this turns out incorrect because of this fact right here. And this is the correct answer, negative rad 33. So be careful with that. There's like a little trap hanging out there, just waiting for you to step in it. Always convert to I's first. I'll say it that way. Okay, let's take a look at C. Here we have rad negative 80 divided by rad negative 10. So let's first begin by taking this negative out as an I on both of these. Okay, so this gives us I rad 80 over I rad 10, and those I's cancel out. Okay, so now we just have rad 80 over rad 10, which we can happily write inside of a single radical. The I's are gone, so it's fine to do this. That leaves us with rad 8. Well, 8, we're looking for a perfect square inside 8, 4 and 2. 4 is our perfect square, so we'll write this rad 8 as rad 4 times 2. And then 4 is our perfect square, so rad 4 is 2, leaving behind a 2 inside the radical, 2 rad 2 for that one.